Good day, grade 4 pupils. It's a brand new day and a good chance to learn. Get ready and let's learn mathematics right at the comfort of your home. Come with me as we discover and conquer the world of mathematics. Come on, get your pen, paper, and self-learning module. But before we proceed, I want you to do the following. First, type in your complete name, grade and section, your subject teacher, and your school in the comment box so your teachers would recognize your attendance. Second, if you like to answer during our discussion, simply type in your answer in the comment box. And finally, if you have some questions about the lesson discussed, you may also type in your questions before the session ends so your teachers would recognize your participation. For today's lesson, you will learn how to write a given number as a product of its prime factors, greatest common factors, or the GCF, common multiples, and the least common multiples of two numbers using the following methods: the listing method, the prime factorization, and the continuous division. I have here an activity. I will give you 30 seconds to tell me whether the number in the snail is a prime or a composite numbers. Are you ready? So your timer starts now. Let's check your work. So we have here 8. Is it a prime number or composite number? Very good. The answer is composite number. Next is 7. Very good. It is a prime number because the factors of 7 are 1 and itself. Now, how about 12? Is it a prime number or composite number? Very good. That is a composite number. Now, how about 21? Excellent. That is a composite number. And last one, we have 13. That is a prime number. It is very important that you know what is a composite number and a prime number because we will use that in our discussion. To start our lesson, I have here a problem. Roger has 29 coins in his coin collection. Lauren has 32 coins in her coin collection. Which number has more factors, 29 or 32? Let's analyze the problem. What is asked in the problem? Very good. Which number has more factors? What are the given facts that can help to solve this problem? Yes, Roger has 29 coins and Lauren has 32 coins. To solve this problem, we will list down the factors of 29 and 32. The factors of 29 are 1 and 29. While the factors of 32 are 1, 2, 4, we have 8, 16, and 32. It is obviously that 32 has more factors than 29. Composite numbers can be factored into a product of prime factors. This process is known as a prime factorization. We can get the prime factors of a composite numbers by using the methods of factor tree and the continuous division. For example, let's get the prime factors of 24 by using factor tree and continuous division. To get the prime factors by using a factor tree, let's factor 24 into 4 times 6. But you can also use 2 times 12 and also 3 times 8. However, 4 and 6 are not primes. So let's factor 4 into 2 times 2 and 6 into 2 times 3. We will not factor 2 or 3 any further because they are prime numbers. Therefore, the prime factors of 24 are 2 times 2 times 2 times 3. Now, let's use continuous division to get the prime factors of 24. Let's divide 24 by its prime factor. We will think of a prime number that we can divide into 24. Very good. We can divide it by 2 and we will put this continuous division symbol. 24 divided by 2 is, very good, 12. And we will place it below 24. Again, let's think of a prime number that we can divide to 12. We can divide 12 by 2. And the answer is 6. 6 still have a prime factor. So let's divide 6 by 2. And the quotient is 3. 3 can be divided by 3, which is a prime number. And 3 divided by 3, the quotient is 1. We will stop the division until the quotient is 1. Therefore, the prime factors of 24 are 2 times 2 times 2 times 3. Let's have another example. Let's get the prime factors of 18 by using the factor tree and the continuous division. To get the prime factors by using a factor tree, let's factor 18 into 3 times 6. But you can also use 2 times 9. Now, 3 is a prime number. But 6 is not a prime number. So let's factor 6 into 2 times 3. We will not factor 2 or 3 any further because they are prime numbers. Therefore, the prime factors of 18 are 2 times 3 times 3. Now, let's use now continuous division to get the prime factors of 18. We will divide 18 by its prime factor. We will think of a prime number that we can divide to 18. Very good. We can divide it by 2. And let's put this continuous division symbol. 18 divided by 2 is 9. And let's place it below 18. Again, let's think of a prime number that we can divide to 9. We can divide 9 by 3, and the answer is 3. 3 can be divided by 3, which is a prime number, and 3 divided by 3, the quotient is 1. We will stop the division process because the quotient now is 1. Therefore, the prime factors of 18 are 2 times 3 times 3. Now, let's have another example. Let's get the prime factors of 32 by using again the factor tree and the continuous division. To get the prime factors of 32, let's factor 32 into 4 times 6, but rather 4 times 8. But you can also use 2 times 16. However, 4 and 8 are not primes. So, let's factor 4 into 2 times 2 and 8 into 2 times 4. 4 is still not a prime number. So let's factor 4 into 2 times 2. We will not factor 2 any further because it is a prime number. Therefore, the prime factors of 32 are 2 times 2 times 2 times 2 times 2. Now, let's use continuous division to get the prime factors of 32. Let's divide 32 by its prime factor. We will think of a prime number that we can divide to 32. Very good. We can divide it by 2 and we will put this continuous division symbol. 32 divided by 2, the answer is 16 and we will place it below 32. Let's think again of a prime number that we can divide to 16. Very good. We can divide 16 by 2 and the quotient is 8. 8 has still have a prime factor. So let's divide 8 by 2 and the quotient is 4. Again, 4 divided by 2 is equal to 2 and 2 divided by 2 is equal to 1. Now, we will stop the division because the quotient now is 1. Therefore, the prime factors of 32 are 2 times 2 times 2 times 2 times 2. We can see that whether we use a factor tree or continuous division, the result of the prime factors is the same. Now, get a pen and a paper, and you need to find the prime factors of the following numbers using either factor tree or continuous division. I will just give you 1 minute to solve this. Find the prime factors of the following numbers using either factor tree or continuous division. So the number is 36. So your 1 minute starts now. You can do it, grade 4 pupils. "30 seconds left. "20 seconds left. Okay, time's up. Let's check your work. So we can use factor tree and continuous division. Now, in factor tree, the factors of 36 are 4 times 9. But you can also use 2 and 18 and 3 and 12. So I'll use here 4 and 9. 4 times 9 are still not a prime number. So we will factor, we will factor 4 into 2 times 2 and 9 into 3 times 3. Now, they are all now prime numbers. Therefore, the prime factors of 36 are 2 times 2 times 3 times 3. Now, we will use now continuous division. 36, we will divide 36 by its prime factor, which is 2. 36 divided by 2 is 18. And we will divide 18 by 2. 18 divided by 2, the answer is 9. And then, we can divide 9 by 3. 9 divided by 3, the quotient is 3. And 3 divided by 3, the quotient is 1. We will stop the division process because the quotient now is 1. Therefore, the factors of 18, of 36 are 2 times 2 times 3 times 3. Did you get the same answer? Very good. Now, How about 54? You will get the prime factor of 54 using either factor 3 or continuous division. So your 1 minute starts now. Forty seconds left. Thirty seconds left. Twenty seconds left. 10 seconds left. Okay, time's up. Let's check your work. So we are asked to find the prime factors of 54 by using either factor 3 or continuous division. Now, by using factor 3, the factors of 54 are 6 and 9. But you can also use 2 and 27 or 3 times 18. Now, 6 and 9 are not yet prime numbers. So we will factor 6 into 2 times 3 and 9 into 3 times 3. Now, 2, 3, 3, and 3 here are all prime numbers. Therefore, the prime factors of 54 are 2 times 3 times 3 times 3. Now, by using continuous division, we will divide 54 by 2. And then 54 divided by 2, the answer is 27. 27 divided by 3, the answer is 9. 9 divided by 3, the answer is 3. And 3 divided by 3, the answer is 1. Therefore, the prime factors of 54 are 2 times 3 times 3 times 3. Did you get the same result? Excellent! Just remember, grade 4 pupils, that prime factorization is a process of expressing a number as a product of its prime factors. And the two methods commonly used to find the prime factors of numbers are using factor 3 and continuous division. Now, let's move on to our next topic, which is finding the greatest common factor, or the GCF, and the least common multiple, or the LCM, of two numbers. We can find the GCF and LCM of two numbers by using listing method, prime factorization, and continuous division. For example, let's find the GCF of 8 and 12 by using the listing method. We will list down all the factors of 8 and 12. The factors of 8 are 1, 2, 4, 8. And the factors of 12 are 1, 2, 3, 4, 6, and 12. The common factors of 8 and 12 are 1, we have 2, and 4. Therefore, the greatest common factor, or the GCF, of 8 and 12 is 4. Very good. Let's have another example. Let's find the GCF of 18 and 24 by using the listing method. We will list down all the factors of 18 and 24. The factors of 18 are 1, 2, 3, 6, 9, and 18, while the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. The common factors are 1, We have 2, we have 3, and we have here 6. Therefore, the greatest common factor of 18 and 24 is 6. Now, let's move on finding the least common multiple by using now the listing method or the LCM. Let's find the LCM of 12 and 20 by using the listing method. Now, we will list down the multiples. Again, the multiples of 12 and 20. The multiples of 12 are 12, 24, 36, 48, 60, 72, and so on and so forth. The multiples of 20 are, we'll just skip count by 20. We have 20, 40, 60, 80, and so on. Take note that you will not stop listing the multiples of two numbers until you find a common multiples. Again, take note that you will not stop listing the multiples of two numbers until you find a common multiples. In the multiples of 12 and 20, the least common multiple is 60. Therefore, the LCM of 12 and 20 is 60. Now, let's find the LCM of 24 and 36 by using the listing method. We will list down the multiples of 24 and 36. You may use the skip counting of 24 and 36. So we have here 24, 48, 72, 96, and so on and so forth. How about 36? The multiples of 36 are 36, 72, 108, and so on and so forth. Take note that you will not stop listing the multiples of two numbers until you find a common multiples. In the multiples of 24 and 36, the least common multiple is 72. Therefore, the least common multiple or the LCM of 24 and 36 is 72. Let's discuss now how to find the GCF and the LCM of two numbers by using the prime factorization. Let's find the greatest common factor and the least common multiple of 8 and 12 by using prime factorization. Let's find the prime factors of 8 and 12. Let's factor 8 into 4 times 2. However, 4 is not a prime number, so let's factor 4 into 2 times 2. We will not factor 2 any further because it is a prime number. Therefore, the prime factors of 8 are 2 times 2 times 2. Now, let's factor 12 into 4 times 3. However, 4 is not a prime number, so let's factor 4 into 2 times 2. We will not factor 2 any further because now it is a prime number. Therefore, the prime factors of 12 are 2 times 2 times 3. Now, listen very carefully. To get the greatest common factor or the GCF, let's multiply all the common prime factors. The common prime factors of 8 and 12 are 2 and 2. Therefore, the GCF is 2 times 2, which is 4. Now, to get the least common multiple or the LCM of 8 and 12, let's multiply the common prime factors, which are 2 and 2, and the remaining prime factors, which are 2 and 3. Let's multiply the LCM 2 times 2, which is the common prime factors, and the remaining prime factors, which are 2 and 3. So 2 times 2 times 2 times 3, the answer is 24. Therefore, the least common multiple or the LCM of 8 and 12 is 24. Now, let's have another example. Let's find the greatest common factor, the GCF, and the LCM of 18 and 24 by using prime factorization. Now, let's find the prime factors of 18 and 24. Let's factor 18 into 9 times 2, but you can also factor it into 6 times 3. However, 9 is not a prime number, so let's factor 9 into 3 times 3. We will not factor 2 and 3 any further because they are prime numbers. Therefore, the prime factors of 18 are 2 times 3 times 3. Let's factor 24 into 4 times 6. But you can all factor it into 2 times 12 and 3 times 8. However, 4 and 6 are not prime numbers. So let's factor 4 into 2 times 2 and 6 into 2 times 3. We will not factor 2 and 3 any further because they are now prime numbers. Therefore, the prime factors of 24 are 2 times 2 times 2 times 3. Again, to get the GCF or the greatest common factor, let's multiply all the common prime factors. The common prime factors of 18 and 24 are 2, and we have here 3. Therefore, we will multiply 2 and 3 to get the GCF. The GCF now is 6. Now, to get the least common multiple or the LCM of 18 and 24, let's multiply the common prime factors, which are 2 times 3. Yan. And then the remaining the remaining common prime factors are LCM, 2 times 3 times 3 times 2 times 2, which are the remaining common prime factors. 2 times 3 times 3 times 2 times 2, the answer is 72. Therefore, the LCM of 18 and 24 is 72. Now, let's talk about finding the GCF and LCM using now continuous division. Let's find the GCF and LCM of 8 and 12 by using continuous division. Let's divide 8 and 12 by its prime factor. We will think of a prime number that we can divide to 8 and 12. Very good. We can divide 8 and 12 by 2, and we will put this continuous division symbol. 8 divided by 2, the answer is 4. Very good. And we will place it below 8. 12 divided by 2, the answer is 6. And then let's think again of a prime number that we can divide by 4 and 6. We can divide 4 and 6 by 2. And the quotient is 2 and 3 respectively. 2 and 3 has no common prime factors. So, we will stop the division because there are no common prime factors in the quotient. To get the greatest common factor or the GCF, let's multiply all the prime divisor. So, we have 2 times 2. Therefore, the GCF now is 4. Now, to get the LCM or the least common multiple of 8 and 12, let's multiply the prime divisor, which is 2 times 2, and the remaining quotients, which are 2 and 3. So, if we multiply 2 times 2 times 2 times 3, the answer is 24. Therefore, the least common multiple of 8 and 12 is 24. Now, let's have another example. Let's find the GCF and LCM of 18 and 24 by using continuous division. Let's divide 18 and 24 by its prime factor. We will think of a prime number that we can divide to 18 and 24. Very good. We can divide it by 2. And we will put this continuous division symbol. 18 divided by 2, is 9, and we will place it below 18. 24 divided by 2 is 12, and we will put 12 below 24. Let's think again of a prime number that we can divide to 9 and 12. Very good. We can divide 9 and 12 by 3, and the quotient is 3 and 4, respectively. 3 and 4 has no common prime factors. So we will stop the division because there are no common prime factors in the quotients. Now, to get the greatest common factor, the GCF, let's just multiply all the prime divisors, which are 2 and 3. Therefore, the GCF is 2 times 3 is 6. Now, to get the LCM, let's multiply the prime divisors, which are 2 and 3, and the remaining quotients, which are 3 and 4. LCM now is 2 times 3 times 3 times 4, and the answer is 72. Therefore, the least common multiple of 18 and 24 is 72. We can see that whether we use a listing method, a prime factorization, or continuous division, the result of the GCF or the greatest common factor and the LCM or the least common multiple is the same. Now, it's your turn. In 1 minute, I want you to find the GCF of 16 and 24 using any methods. So your 1 minute starts now. $30 left. You can use listing method, prime factorization, or the continuous division. $10 left. Okay, time's up. Let's check your work. So again, the listing method will list down all the factors of 16 and 24. So the factors of 16 are 1, 2, 4, 8, and 16. While 24, the factors are 1, 2, 3, 4, 6, 8, 12, and 24. Now, the common factors are 1, we have 2, we have 4, and 8. So the greatest common factor of 16 and 24 is 8. Now, if you use here na prime factorization, we'll just factor, rather the prime factors of 16 are 2 times 2 times 2 times 2, and the prime factors of 24 are 2 times 2 times 2 times 3. The common prime factors are 2 times 2 and 2. To get the GCF, we will just multiply the common prime factors. Therefore, GCF now is equal to 2 times 2 times 2, and the answer is also 8. Now, if we use now continuous division, so 16 and 24, so we can divide it both by 2. 16 divided by 2, the answer is 8. 24 divided by 2, the answer is 12. Again, we will divide 8 and 12 by 2. 8 divided by 2 is 4, and 12 divided by 2 is 6. 4 and 6 can be divided by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. So we'll stop the process because the quotients have not common prime factors. Now, the GCF now is 2 times 2 times 2, which is also 8. Therefore, the greatest common factor of 16 and 24 is 8. Did you get the same answer? Very good. Now, for your next activity, how about you find the LCM of 16 and 24 using any methods. So your 1 minute starts now. You can use listing method, prime factorization, or the continuous division. So you have 40 seconds left. Twenty seconds left. Ten seconds left. Oops, time's up. Let's check your work. So we asked to find the LCM of 16 and 24. Now, first, we will use the listing method, 16 and 24. We list down all the multiples of 16 and 24. So we will skip count by 16. We have 16, 32, 48, 64, and so on and so forth. How about 24? We have 24, 48, 72. So we have here a common multiple, which is 48, and that is also the least common multiple. Now, if we use prime factorization, the prime factors of 16 are 2 times 2 times 2 times 2, while the prime factors of 24 are 2 times 2 times 2 times 3. The common prime factors are 2, 2, and 2. Now, to get the LCM, we will just multiply the common prime factors, which are 2, 2, and 2, and the remaining prime factors, which are 2 and 3. So we have here now 2 times 2 times 2 times 2 times 3. The answer is also 48. Now, if we use now continuous division, 16 and 24, we can divide 16 and 24 by 2. 16 divided by 2 is 8. 24 divided by 2 is 12. We can divide 8 and 12 by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. We can divide 4 and 6 by 2. 4 divided by 2 is 2. And 6 divided by 2 is 3. So, to get the LCM, we'll just multiply the common prime divisors, rather the prime divisor, which are 2 times 2 times 2, and the remaining quotients, which are 2 and 3. Therefore, the LCM is 2 times 2 times 2 times 2 times 3, or 48. Therefore, the least common multiple of 16 and 24 is 48. Did you get the same result? Excellent! Just remember, grade 4 pupils, that to find the greatest common factor, or the GCF, and the least common multiple, or the LCM of two numbers, we used listing method, prime factorization, and continuous division. So you have pre-test quarter 2, week 2. And then again, I'm your teacher Roel from Apollonia F. Rafael Elementary School, saying anuman ang sitwasyon, tuloy ang edukasyon. Goodbye! See you again next time!